So, does every series converge? No, it does not. Now, let's look at a series that is a little bit more interesting than just trying to add one to itself infinitely many times. Let's look at a series that goes 1 plus a half plus a third plus a quarter plus a fifth and so on. This gets the special name the harmonic series, going back to some ancient ideas in music, thanks to Pythagoras. And we're going to show why this series diverges. So yes, this series has a nice formula. However, that is not going to be enough to get us convergence. So let's look at partial sums where we've added up 2 of the elements on the list, and then add up 4 of the elements on the list, and then add up 8 of the elements on the list. So doubling every time. That'll make things a little bit more convenient. Well, S2, the partial sum, number 2, is just 1 plus a half. S4, the partial sum number 4, is 1 plus a half plus a third plus a quarter. However, a third plus a quarter, well, a third is larger than a quarter, so I know that S4 has to be bigger than 1 plus a half plus a quarter plus another quarter. I made this sum slightly smaller, and I got 2. Okay, let's keep going. What happens at S8? Partial sum number 8 says we take we take 1 plus a half plus a third plus a quarter plus a fifth plus a sixth plus a seventh plus an eighth. And now we've put in some parentheses here to make the argument a little bit more obvious. What's going on? All the fractions in this first set of parentheses are larger than 1/4, greater than or equal to, I should say. All the fractions in the second set of parentheses, there are 4 of them. Each of them is greater than or equal to 1/8. So S8 is going to be smaller than, S8 is going to be larger than 1 plus a half plus another half plus another half, which is 1 plus 3 halves. I can do the same kind of thing with S8 as I did. I can do the same kind of thing with S16. So that I have some number which must be larger than 1 plus a half plus another half plus another half plus 1 more half. So S16 has got to be at least 1 plus 4 divided by 2. So it's got to be at least 3. So this means that every single partial sum, as long as we're taking these powers of 2 for which numbered partial sum we have, S32 has got to be bigger than 1 plus 5 halves. S64 has got to be bigger than 1 plus 6 halves. So in general, S2 to the n, right? Take the first 2 to the n numbers on the list, add them all up. That has got to be bigger than 1 plus n divided by 2. But we can take the limit of 1 plus n divided by 2. That's going to be infinity. So this argument is showing us why the sum of the harmonic series has to grow unboundedly. So that sum will diverge. There is not a real number that we can assign it a value.